All right, let's jump right into it. So I named this webinar Across the Thingiverse, kind of a stylized title from the film itself, Across the Universe. Thingiverse, for those of you who don't know, is a giant 3D file, digital 3D file repository online. It's owned by Ultimaker / MakerBot. I know they had a merger this year. And what we're going to be doing is we're going to be randomly selecting 3D models to download, slice them, kind of walk you through how we would slice these files with the intention of printing on a filament style or FFF style printer. And because MLC CAD systems being a VAR and supporting Markforged, we are going to be using Markforged slicer called Eiger. So here you can see I threw the little 3D benchy instead of the strawberry that's usually on the movie poster, and did some clever editing on our two characters here being Eiger and the Ultimaker symbol there. So let's get started. All right, before we jump into Thingiverse and kick off this webinar, I want to talk about the rules. So for one, we're going to be selecting parts at random from Thingiverse, as I mentioned earlier. We're going to be only selecting parts that are free to download. We're not going to be paying for anything. We don't want to do anything that's too overly complicated, has like tons of different components and it's like crazy geometries. Just kind of keep it relatively simple. And lastly, we're not going to be choosing any parts like weapons, anything that's kind of controversial. And for those of you who might be familiar with the channel Maker's Muse, it's run by Angus Devison. He actually came up with a very similar concept. He called it the slicing Gauntlet. And he went through and downloaded files from Thingiverse and kind of followed these same steps. So we took heavy inspiration from his idea. And we hope you enjoy. Now, if I go ahead and jump into Thingiverse here, this is kind of your home page when you first click on it from your web browser. And what you'll notice is if I were to select any one of these parts, say this part right here, if we go up into the URL, you'll identify that there is a number tied to every part. So this part here is 6,300,840. As I mentioned earlier, Thingiverse is a massive file repository. There's literally millions of parts that are on this site. And so the intention here is using a random number generator. This is just one straight from Google. If I choose a minimum of 1 and I'll choose a maximum of 10 million. Okay, 1 to 10 million. And I'm just going to randomly generate a number in between those ranges. All right, so here I've got a 4.6 million magnitude value. I'm going to select this and I'm going to fill that number in for this last bit. Okay, sweet. So we actually had a part for the first run. This is pretty awesome. As you might imagine, there are some numbers that do not have a part that's tied. So you might choose a number to a file that was maybe removed by the user, and you'll hit like a 404. And so we just got to keep continually random number generating until we hit a part. So this looks like "In John Moses Browning We Trust." Psalm 1911. Okay, so it's a plaque commemorating the 1911 pistol. I don't think this is too dangerous. It's not actually a usable weapon of any kind. So we'll go ahead and choose this file here. As long as, okay, it looks like it's a free to download. So it's actually two separate parts. You have the 1911 half, and then you have the plaque itself. So we'll go ahead and we'll just download these individually. So we got that one, and then I'm just going to download this one right here. Okay, awesome. All right, so we got those files. Now let's go and generate another one. All right, now we're at like 9.5, almost 9.6 million. Grab this one. And we'll just do the same thing, just delete this out. Okay, yeah, so that's a 404. And it says you've reached the end of the Thingiverse. There's no actual part tied to that number. So let's do it again. Oh my gosh! Finally. Oh, look at that! It's a temperature tower. This might be too basic. Let's keep going, even though it pains me to do so. Oh, nice, dude. What is this? Name keyring. Alright. We'll download this file here. And let's keep on going. Britain's MacBook Air? What on earth is this? This is my computer. I made it in Tinkercad. What the heck? Yeah, this is like, I mean, you can see it's like infinitesimally thin here. I figured this was going to be a weird thing here. I don't like this model. This model is going to be ugly. Oh, sweet. Alright, another keychain. Looks like someone's name or something. Sure, we'll download this. Alright, let's go back to it. 0.6 mil. Oh, another file. Let's go. Alright. Download this one. Damn, 21 meg. That's pretty big. Hey. Hey, this is a really good one. Sweet. Ooh. 45-degree light mount. Okay. This is interesting. I like this. Oh my gosh. I'm in tremendously good luck right now. Okay. So a little wrench. Beater. Okay, let's do this. Get this one. This one actually might be interesting. It's just a message ring. Hopefully it doesn't say anything bad. This one's just too basic. I think we have plenty of parts like this already. I'm gonna keep going. Oh! Ah! Another ring band. Oh! Ender 5 bed level stops. Okay. I'll choose this. It's an interesting one. Oh, ooh! What is this? Hot glue stick inlay. You can lay glue sticks inside a tray. That's interesting. Simple though. I don't want to go that simple. Oh, what the? Grass box flap for a still Viking. Looks like there's some kind of artifacting here. Like it's a really thin surface or something. I may pass on that just in case it's something strange. Laptop desk hanger. Sure, we'll print this. Alright. See if there's anything else. Oh man, I'm on a roll. I think we have enough plaques. Yeah, see again, it's just like flat lettering. It's too basic. Oh! This is really cool. Here's a one-piece STL, and here is a separate piece STL. This is an interesting one. I would like to look at this. Okay, I think we have enough parts. We have quite a few to look at. So I think at this point, I'm going to leave this, and I'm going to open up Markforged Eiger. I'm just going to jump into my models here, and let's start with start importing some of these STL files. So I can just select it from here. I can select it from up here in the upper right. I'm just going to select this. I'm just going to set a default config. And then from this blue box, it's saying, hey, click here or just drag the files into this region. I'm just going to click here. And here I have the files. And I'm just going to set it to the date in which I downloaded it. So we'll grab this file first. This is the black. Click import. And you can see it's just a large flat plate, as we might expect, especially as we saw. And see, I can just select a face. You can do this in just about any slicer. You can just simply select like some kind of bounding box, and you can select any number of these flat faces. But this one would be perfectly fine to print in this orientation. So if I were to, choose just all the default settings, 0.1 layer heights, I'm going to toggle off supports. We actually don't need supports for a part like this. There's no drastic overhangs. These settings here for your infill structure, these are all optimized for print speed, for print quality, for strength by Markforged. They spend a lot of time trying to figure out the best permutation of different values here, so I'm going to leave those as is. And like everything else, we're just going to use their Onyx material, which is a nylon 6 with chopped carbon fiber. I'm going to click save. Okay. And you'll notice that over here on the left now we have some feedback from the slicer letting us know how long this part's going to take to print, how much material is going to be used, and the cost of said material. Now what I'm going to do is I'm just going to jump into the X-ray mode here, and I always like to just double check and make sure there's nothing strange going on with the sliced model. So I can just kind of step through these layers here. So see, these are these 1, 2, 3, 4 floor layers before we jump into the infill. That's part of those defaults that Markforged put in. And we can see here that all the lettering here is thick enough to where material is going to be able to be filled inside each letter. So there's no issues with lettering and the thinness of the lettering. Even some of these thinner regions are going to print just fine. So I'm not too concerned with that. So at this point, I could go ahead and click print down here. There, it just loads it onto the bed. Choose a printer in our organization. So we have a number of desktop machines in various locations along the southern United States. I could also feel free to just export this build, save it to a thumb drive, and plug that thumb drive into the back of the printer. Alright, so with that in mind, you just select this, jump back into our part view, jump back into our subfolder. Alright, let's open up I believe it's the half of that 1911. Should be this next one here. Throw this one in. This one's going to be also pretty similar. It's interesting how they have those little channels in here. You can see there's a little bit of artifacting on this gun just from the way that it was modeled. But just something like this, honestly, something like this could have been printed on that plaque. It could have been exported as one file instead of two separate STLs. But something like this could print just fine. We could, I don't need supports, keep all that the same, print in an Onyx, click save. I'd like to jump into X-ray mode for this because there's some pretty thin features on this gun. Yeah, you can see how the trigger guard is so skinny here that only two little dots are printed. So that would have to be something where you might want to like scale this part up a little bit. I'm also really not sure why they decided to make this feature like a separate item. Like, why didn't they just connect this channel? It's a little bit strange. I'm sure it'll print fine, but it's like, why add all that complexity? So for a part like this, you could go into settings, and we could scale this up like maybe 10%. Give that a shot. Yeah, so you can see now we're getting more and more material filled in here. You get the idea. May have to scale it up to 50% increase size. And we had plenty of room from the plaque, so we could definitely opt to do that. Honestly, I would just go back and thicken that up. That's where some of your design for additive principles kind of come in. You know, when you're going to make a feature that's real skinny like this and you're not sure if it's going to survive, have that design guide with you. Have some little unit tests that you've printed so that you know, okay, this is the smallest post, this is the thinnest feature. And that way, when you're going to model this, there's no guesswork. You just know exactly what you need to stay within, what kind of boundary you're looking at, and you can go from there. But otherwise, the same process applies to the plaque. Just go to click print, select your printer, click print again, and you're ready to go. All right, let's jump right back into our subfolder, and let's take a look at our next part. This down. And our next part, okay. This keyring and this keychain are both very similar. Very similar. So I think I may skip this one, and I think this one is a little bit more interesting. And we'll just do the same thing, kind of orient it on that large flat face. That's kind of what you'll notice is I'm looking for that large flat face, something that's going to impart strength, it's going to impart good surface finish, but it's also going to print successfully with minimal supports. So this looks like someone's name. Again, I don't see any drastic overhangs on this part. Everything is firmly planted on the bed. So I just toggle off the supports. And again, we're just going to leave that infill, these values the same. And we're just going to keep the material to Onyx and click Save. Go into X-ray mode. And same thing applies, just stepping up through these layers, specifically at these finer features, these lettering. The lettering here is really what I want to take a look at. But you can see everything has a 2-layer perimeter. See there's an infill structure applied to everything. And that's kind of those top layers. Even the thinness of this cursive Y is able to print just fine. So this would be easy part to print. Okay, this is that statue. And see, one of the comments I made when I downloaded this is it's over 20 meg, and Markforged Eiger does better with STLs under 20 megabytes, which really, you don't need to tessellate models to such high an extent that the files are over that 20 meg. But it's got a nice flat base here. And the nice thing is, from what I can tell, even the overhangs of these chins might be fine enough. May not be shallow, too shallow. So we can go ahead, choose that. I'm going to turn supports off because it's definitely going to want to generate material there, and I don't think we need any. And we'll go ahead and click Save. All right, I'll go into X-ray mode. Yeah, if we wanted to be safe, we could definitely have support material. We'll see how that looks. The nice thing with Eiger is it's auto-generating supports. It's identifying these overhang regions, and it's automatically placing supports to support those overhangs. So it's supporting like the chin region, part of the hair, this kind of top bit of the flange. At this point, I'm good with printing this file. This one has some interesting ways to support it. So what I would do, okay, so if I were to support this, or print this like in this orientation, you can see that the support that's going to be generated for these tabs, right? These are pretty sizable overhangs, and we have to support them. Otherwise, the molten plastic is going to droop, and we're going to have some serious dimensional issues. So even though the support that's generated is not very tall for these 3 tabs, it's going to be very tall up in here. It's going to have to support this entire, basically, bottom section, the bottom floor of the tray. So for a part like this, it would be better to print it in this orientation. That way, the inner surface of the tray is very smooth and clean, and we just have to add some supports for these tabs out here. And because of the way the print bed's oriented, what I might do is just rotate this part, red band here, and just rotate this. Okay, I like that. Not to mention these holes will print more accurately in this orientation as well. We're going to leave the support toggle on. We're going to leave our infill pattern the same. And you could leave the layer height at 0.1, or you could jump it up, just let it print a little bit faster. For a part like this, I might do that. I'll select 0.2 for this part. And again, Markforged is automatically generating supports in these areas. If I go into 2D mode, you can see how support material is printing in the same material as the part itself, but it produces a very rough accordion pattern. And what that allows is for minimal amount of material to be used as support, because it is going to be stripped away and thrown away. And so here you can see it's producing that pattern all the way up until the actual feature itself is printed. And it's just going to print straight on top of this. Now we do have the ability, if I go back into our part view, I do have the ability to go into our settings. And down here at the bottom, there's a number of toggles, and one of those toggles is for turbo supports. So it's going to print the supports more coarse, and it's going to print them at a higher layer height. So I'm going to toggle that on. If we go back into our X-ray mode, you can really see how much coarser these folds and these patterns are. And if we toggle up, right as we get up to the feature, we're going to go back to kind of that default accordion pattern. It's a bit tighter, and you can see it's just resting on top of the coarser version. And at this point, this part is ready to print. So this one has a lot of different flat surfaces. I could like print it like this. I could print it like this. I could print it like this. There's a lot of different options here. And this is a really good part to look at. So with this here, in this orientation, right, we have some overhang concerns here. That might be an issue. Let's see, what else do we have? What you'll notice is that this is oriented at 45 degrees, and 45 degrees is like the threshold limit. So if you start to, and we're talking about 45 degrees from horizontal, if you start decreasing that angle down to 40, 35, whatever, you're going to have to support that feature. So because this is at 45, we are very free to not have any supports here. If we support it like this, you can see we would need some support material in this region. And because this is basically going to be supporting a corner, it's going to be a little bit strange. If we like angled it like this, kind of have that same issue here. So I think putting it like this, plus we got these bolt holes here, and holes always print better in that XY plane. I think this is going to be our best bet for printing this part. And what I'm going to do is I'm going to, I think because of the features and everything, I might leave that at 0.1. We'll keep all these the same, and I'm going to go ahead and click Save. Now, Eiger is going to support even 45 degree angles, so that's one thing that we have to contend with. So we're going to have to do some removal of supports on this part. I think I'm going to leave this here But I can actually remove this support, and this support. There's no reason why we really need to have that. So I'm going to go create new override. I'm going to go remove supports, add sketch, click rectangle, and I'm going to draw kind of a rough rectangle. You can see I can modify it after the fact, but I'm going to see if I can, how far I can get it. Oh man, that's going to work really nicely. And again, I can overshoot it. It doesn't have to be that precise. Click finish sketch. Then I'm going to drag this all the way up, say to layer 580. And we'll click reslice and save. Awesome. Okay, so I just need to probably add a little bit of support blocker right in this region. It's just where that rectangle didn't hit. So let's go ahead and do that. Go back into 2D mode, and this time I can start the support blocker higher up. Okay, so it's generating right in here. So we'll start it at like 135. Again, we'll say remove supports, add the sketch, do this, kind of just draw like an oversized rectangle here, finish sketch, and we'll just do the same thing, just drag it all the way up. Say 550, we'll keep it even, reslice and save. All right. So I just want to reiterate, again, we're talking about the 45-degree angle rule, and all these are at 45 degrees. And so all these can be, these are all self-supporting features, and so we don't need any supports in here. Markforged Eiger is just very conservative, and they just want to absolutely guarantee a successful print. So they're still going to add some supports for 45 degrees, but we really just need supports in this, since that's a kind of a direct overhang. And yep, should be good from there. So this wrench is pretty interesting. Again, I'm selecting that large flat face. I think you're starting to identify the pattern here. One of the reasons I want to select the face that I've just chosen, this one down here, is because if I were to select this face, you can see I've got a this region here is not touching the print bed. So I'm going to have support material there. Not to mention I'm dealing with counterbore objects, so I have to have supports generated up here, and I have to have supports generated on this face here. So we want to eliminate support material as much as possible, because it means that the print time is longer. So we want to go this route. The other thing too is with this model, it looks like there's a lot of like fillets. There's a lot of fillets here. When you're going to design parts with the intention of 3D printing, it's always better to route chamfers instead of fillets on these surfaces. You can, say you really need a fillet in this area, you can kind of do what's called like a faux fillet, where you put a chamfer in to start with, and then you fill it off the rest as you transition from the chamfer to that vertical face. But fillets, the thing is with fillets is that right in the very beginning of the fillet, you have a very gradual overhang. You have overhang that's less than 45 degrees. And so you can get some ugly surfacing in those regions. You can put support material here, but it's going to print like a single layer of supports, and I just don't think that's worth it. So in this case, I would just leave support material turned off. And we'll keep everything else the same. Just jump into 2D here. And I don't suspect of it having any issues here. Everything looks totally fine. This is a really interesting thing. So we saw how parts that had lettering oriented on the XY plane printed a certain way. We're going to look at lettering now printed in the XZ or YZ plane. And I'm going to do this at 0.1 layer height, print it that, doesn't need supports, keep infill. With a part like this that's really small, this would be a great example of opting for maybe a solid fill. Let me do this though. Let me slice it first and go into X-ray, because it may be better, instead of doing solid, it might be better to increase our wall layers. So let's try that. 2D. Okay, well, in this case, it can only fit 2 layers, so we're good there. And then you can see it's all these letters have these interesting little features here. And so at this point, you'd want to go ahead and print this. But if you're printing like really thin letters like this, the thing you have to be aware of is the orientation of these letters. So if I'd like to show an example here. You can see how this kind of grill feature has grill slats that are only 0.5 millimeters thick. And you can see that depending on how we orient this part is going to determine whether or not those features print or not. And so by orienting this object vertically, you can see that these slats are now being printed layer by layer as we move up. And you can see because we're printing this part at 0.1 millimeter layer heights, we are producing 5 layers for each slat. Now if we look at it orienting this part this way, on the right, you can see that at 0.5 millimeter layer heights, we're dealing with a nozzle that has a 0.4 millimeter diameter. So we're dealing with a bead width that's about 0.4 to 0.5 millimeters thick. And the slicer is saying that is a geometry that is too thin, and it's outside the threshold which we believe is safe to print this feature. It's not going to print successfully. So it just doesn't register an object there at all. And so that's why you have to be lettering is kind of a similar thing here, where if you take a look at like this sign, for instance, these were printed in 2 different orientations. So the sign at the top was printed on its thin bottom edge, standing up, and on the sign at the bottom, the large flat back plate was printed on the print bed. And you can kind of see a difference. I use Times New Roman as the font because I know because it's a serif font, you have some like really thin regions, and you can see the quality in the font quality difference between these 2 prints, where the one at the top has a lot clearer lettering. It's it's much easier to see, and the one at the bottom just looks a little bit rougher. You can see spots where like some of the lettering didn't actually print and close itself off all the way. And so if you look at this here, you can kind of see a difference where the sign at the bottom, you can see in the preview in Eiger there was actually no material generated in these regions, and it shows on the final part, so that the E in process actually just looks like the C. So this has kind of an interesting geometry on the top. So for this one, probably be better, again we have a large hole here, be better to print this in this orientation. However, you're going to have to print support material inside here because we have this ring. So if I were to turn support material off on this, as we go into 2D and we can preview each layer, once I get to the layer that bridges across these 2 features, so right here, you can see that this is going to run across these paths here, are going to run across, and then it's going to hit here and it's going to have to draw this ring. But see, the layer below it, there's nothing here, so it's going to draw this ring in midair. And that's going to be a problem, right? Because it's just going to sag, and it's just going to fall right down on the print bed. It's not going to go too well for us. So this is where the person who posted this file did something very interesting. So he has a file here called, it's the same name, but it has bridged at the end. And you'll notice there's no hole, there's no through hole. Well, he did something very interesting. Okay, so if I, again, turn supports off, blah, 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 go here, and I scroll up through these layers. So he has 1, 2, 3, 4, and then he starts forming the circle. So he essentially has like 5 layers. And so what he's doing is he's using these as sacrificial layers so that these can be punched through. So it's only a 0.5 millimeter thickness here. And so what you'll notice is that this now can bridge without drawing a circle in the middle of nowhere. And so it's a little sacrificial bit. You can punch through it with a screwdriver or with a drill, and it just saves you from needing support material. Very clever. However, I want to point out something to you. Notice how our first bridge layer, notice how the paths are running vertically. Well, that's not going to do us much good when we're talking about bridging, because we want to bridge between these 2 features. So we need to have these lines running back and forth horizontally, not vertically like this. So what we need to do is go back to the part view, and you need to set the manual rotation, and you need to rotate this about the z-axis by 90 degrees. And we'll click save. And now when we go into X-ray mode and see the 2D preview, we will see that these now are bridging across. So we're now bridging as expected, as we should. This will now print successfully. Okay? So this laptop desk hanger is a really good part to look at because there's a lot of valid orientations for this part. However, because this is going to be supporting a laptop under a desk, we really need to consider strength when we go to print this. So you might be tempted to say, well, let's print it just like this, Joe. I kind of like this orientation. Have just a little bit of support material here. These holes will print in a good orientation in the XY plane. But there is something called layer delamination that is the Achilles heel of FFF printing. And where we're going to have this issue is along this vertical feature, okay, because we're building this layer by layer up from the bed. And these layers, the interlayer bonding on an FFF print is very weak. And so if you're putting a lot of load, right, this is bolted to the underside of a table, and this is where the laptop rests, what you're going to have is you're going to have a lot of stress on this as this is bearing the load. And so what's going to happen is you could have layer delamination and this part could break, and that means your laptop goes crashing to the floor. So for a part like this, you would be probably better off orienting it like this, because now you can see the layer lines generating up this way, and we're not going to have any layer delamination risk. So it's a much safer way to orient this part. Also, these should probably bridge just fine. However, if you wanted to be safe, you could let Markforged Eiger just generate the supports in those, and you could easily just punch them through. So in this case, we'll just keep all the settings default, click save, and you can see what I was talking about with those fillets earlier. You can see a little bit of support material was generated here automatically because that angle there is less than 45 degrees up until about middle of the way through the fillet. We got some supports in here. We have some supports generated in these holes. If you wanted, you could put in a support blocker and remove those supports, or in CAD, you could add a teardrop shape to the top of that hole, and that would be a perfectly valid option. At this point, this part is ready to print. All right, so as part of our last model, what I'd like to do is go back to the Thingiverse file and show you something with this Stranger Things little kind of desk sign. And that being that when this person created this model, they had the wherewithal to split these parts up. And the reason this is important, splitting up the sign from the stand, is that if you look at the lettering on this, you can see like this region here is going to have to be supported, as is this region. Things like the G, you're going to have a support for this G as well. But by splitting these up, you make printing much easier. Obviously the letters are really thick, so there's not going to be any issues there with any kind of feature loss, as we saw with some of the other parts. It's going to be a very easy thing to print by splitting it up. Alright, so I'm only going to look at the Stranger Things plaque, just because the base is really simple. And what you'll notice right off the bat is I have an error. So Markforged Eiger is really good at feeding back information if there's going to be any risk of a part failing during a print. As you can see, parts in red, I have an error message here in the upper left. And if I click on it, it says, hey Joe, this part's not going to fit. The Z-axis for the desktop machine is not as high as this part. Obviously, if I go to select a flat face here, the error is going to go away. So here is our logo. I don't see any problems here. This is going to print just fine. I'm going to leave everything default. Just going to turn supports off. X-ray mode. You can see here, everything prints perfectly fine. There is no issues at all. Everything looks good. Now, if I were to go in, as I mentioned when I was talking about the file in Thingiverse, if I were to go in and print it like this, let's turn supports back on. Yeah, so it almost gives it a nice backdrop. Lots of supported stuff needed here for all these serifs, for these overhangs, for these drops in the G and everything there. Lots of support material. So now this print is a 9-hour, 21-minute print versus the previous version, which was only 4 hours 17. So it literally doubles the print time essentially. And that's why splitting up your parts and knowing when to do that is very advantageous. It takes a little bit of practice, but once you've mastered that, you're not going to start wasting time, you're not going to waste material, and you're going to have a part that's ultimately going to look better. All right, well, that's all I got for you today. Thanks for joining in on the webinar. We'll open it up to some other questions if you have them. We plan to have maybe a few more episodes, a few more webinars on slicing for filament printing, and also possibly slicing for SLA and SLS printing as well, because there's some pretty interesting techniques with that. But yeah, we'll go from there.